Okay, so 2.7 to 2.8, we're still solving for variables. However, we're going to be focusing today on how we solve for a variable when we're given a proportion. So let's just get those vocabularies down before we move on. So a proportion is an equation that states that two ratios are equal. Okay, if you remember correctly, ratios oftentimes will be represented by a fraction. So you would have, for example, I'd have a fraction a over b equals, let's say 1 over 2. Two fractions, I know they're set equal to each other, okay? We can use cross multiplication to solve proportions. Some of you also, I know, might know the term butterfly method, okay? The butterfly method is another term that I've heard used to describe this, okay? All right, so let's just jump in here. So for number 1, we notice that here's my variable. That's what I'm trying to get by itself. Okay, and in order to solve this one, we're going to do cross multiplication. Okay, so what that means is I'm going to do b times 5. I'm going to multiply the terms that are across from each other. Okay, so I'm going to do b times 5, and I know that that's just b5, or 5b. Then I'm going to do the other way. I'm going to do 6 times 4. Okay, 6 times 4 gives me 24. And now the only new part is I'm going to take this equal sign and I'm going to bring it with me the whole way down. Okay. Now the reason we call this the butterfly method is it looks like a butterfly. Okay, so I'm going to take the purple wing here, set it equal to the pink wing. Okay. Now from here, I have a new equation that looks really simple. I have 5 times b equals 24. I'm going to divide both sides by 5. And then let's see, we're going to get a decimal here. So we're going to do 24 divided by 5, and we get b equals 4.8. Okay? In order to check this, if you want, we can take our 4.5 and plug it in for b. So we'd have 4.5 divided by 6, and we would get 0.8. And then if we tested the other, we should hope that 4 divided by 5 also gives me 0.8. So 4 divided by 5 does in fact give me 0.8. So this checks out. Okay, let's try another one. Let's look at number 2. Again, I start by cross multiplying. So I'm going to do 4 times m, get a 4m. And then I'm going to do negative 3 times 22. Negative 3 times 22, and I know that that's going to give me negative 66. Okay, bring those down. Do not forget to bring down your equal sign. And now from here, I have a nice simple problem. I have 4 times m equals negative 66. Divide both sides by 4. So I have negative 66 divided by 4. I get m equals negative 16.5. Okay, and again, we could check it. So negative 3 divided by 4, that comes from right here. I'm testing this fraction. I get negative 0.75 when I do this guy. And then let's plug in my negative 16.5 divided by 22. And we get the same thing. Negative 0.75, so that checks out. All right, go ahead, try let's do number 3 together. Yeah, let's do number 3. All right, so when we see number 3, notice my variables. I have 2 of them. That doesn't mean I can stop here and panic, okay? You are fine. We're just going to cross multiply the same way we've been doing. So I'm going to do 4 times w, get 4w equals... Then I'm going to do w plus 3 times 2. Now, when we do w plus 3 times 2, we need to be careful with how we write it. 2 times w plus 3 is very different from this. Okay? However, I'm multiplying 2 by the entire quantity of w plus 3. So I'm going to do 2 and then in parentheses, w plus 3. Okay? So now this problem becomes a little more complicated. Here's my mirror line. I'm going to start by distributing, right? Let's just get rid of our parentheses. So I have 2w plus 6 bring down my 4w. Let's keep going from here. I'm going to subtract 2w to get my w's on the same side. So that gives me a 2w equals 6. And last but not least, I'm going to divide both sides by 2 and get w equals 3. Okay? And then you could check that if you want by plugging our 3 back up in here to both equations. Okay, so if I plugged in the 3 up here, I'd get 3 plus 3, which gives me 6. 6 divided by 4 gives me 1.5. So this whole fraction is 1.5. Then I could plug my 3 in up here, and I do 3 divided by 2, and I would get 1.5 again. Okay, so that's just a way to check it. All right, down here at 4, let's try this one more time. Okay, so I'm going to do cross multiply here. So I have 1 times the whole quantity of x plus 1. And then my other wing is 3 times 2, which gives me a 6. Okay, remember that was 3 times 2. All right, so now I'm going to distribute my 1. Now, 1 times anything is just what I multiplied it by, so I'm left with x plus 1 equals 6. Subtract 1 from both sides. I'm left with x equals 5. Okay? All right, I want you to try my next two. Okay, just try them out. They are going to be a little more challenging. Remember, we're multiplying by the quantity. Okay, so think about each of these technically have a parenthesis around them. Okay, go ahead and try to solve. All right, so for my first one, okay, I'm going to do my cross multiplication. So I have 7 times y plus 2 equals, my other side, I have 5 times 2y minus 11. Okay, keeping both sides in parentheses. Now, this problem, I notice I have parentheses on both sides, so I'm just going to distribute on both sides. Okay, so I have 7y plus 14 equals, then on the other side, I'm left with 10y, let's use our blue, 10y minus 55. Okay, so that was just distributing. Now I'm ready to keep solving. Okay, so I'm going to move my y's on the same side. 7y is less, so I'm going to move him to be with the 10y. So I have 14 equals 3y minus 55. Let's keep going from here. I'm going to add 55 to both sides because I'm trying to get y by itself. 14 plus 55 gives me 69 equals 3y. And then I'll divide by 3 and get y equals 23. Okay. All right, if you got stuck on these two, maybe pause and try number 6 now that you saw me walk through one of these. Okay, so number 6, I do cross multiply, so I'm going to do 2 times negative 5b equals 3 times b plus 13. Okay, now my pink sides, I'm just going to do 2 times negative 5 and get negative 10b. The other side, I'm going to have to distribute. So I get 3b plus, and then 13 times 3, I think is 39. Yep, 39. Okay. Now, in a moment, I want us to look at this. When we are moving our variables to the same side, when I look at these two numbers, yes, negative 10 is smaller than 3. However, if I move this negative 10 to the other side, I'm left with a 0 over here. I want to avoid that, okay? So if my b is the only thing over here, I'm going to move whatever's on this side to go b with it, okay? I'm just going to keep my b's on this side. Okay, so I'm going to subtract 3b from both sides. So I'm left with negative 13b equals 39. Then I'll divide both sides by negative 13. 39 divided by negative 13 gives me negative 3. So B equals negative 3. Okay? All right. Let's apply this now because proportions are really useful for us. Okay? So it says an 8-ounce can of orange juice contains about 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in a 12-ounce can of OJ, orange juice, okay? So before we even start problems, remember we're dealing with ratios, right, our fractions. We're going to set up a units ratio before we even start, okay? We'll see why this is important in a minute. So units ratio. So basically we're going to have a fraction. This is our units ratio. And what units am I dealing with in this problem? I see ounces, and I see milligrams, okay, of vitamin C. Okay, milligrams of vitamin C, milligrams of vitamin C. Okay, so it doesn't really matter which place we put them, but just pick a spot. Let's put ounces in the top, and we'll do milligrams in the bottom, okay? You could do it reversed, that's fine, as long as, here's the key, we keep it consistent, which is why we make our units ratio. Okay, so now let's set it up in terms of our numbers. Okay, so our first ratio is going to have to do with the same can of OJ. So I'm told that I have an 8-ounce can of orange juice that contains 97 milligrams of vitamin C. Okay, so where would I put the number 8? In the top, because it's my ounces, right? It should be the same. In the bottom is going to be my milligrams, 97. Okay? Proportions are always one fraction, one ratio equals another. So now let's look at what other information I'm giving. I'm asked about how many milligrams. Okay, so pause. I'm asking you how many milligrams. That should give me a clue that M is going to be my variable. M is going to represent milligrams. And if we're talking about milligrams, where should it go in my fraction? It should go on the bottom with milligrams. Okay? So I'm going to have M there. I'll write it in blue. Okay? All right, and now I'm given 12 ounces. The 12 needs to go up top because it's ounces. Okay, so all we need to do is make sure both my ounces are up top. Both my milligrams are the bottom, even when one of them is a variable. All right, now that I have it set up, I'm ready to solve. So I'm going to cross multiply. So I have 97 times 12. And I get a big old number. I get 1,164 equals 8M. Okay. Now I'm going to divide both sides by 8. So I'm left with M, the amount of milligrams, is 145.5 milligrams. Okay? That's what I'm looking for. An 8-ounce can of OJ contains 97 milligrams of vitamin C. Okay? How many milligrams are there in 12 ounces? 145.5. Okay? All right, a band went to a recording studio and recorded 4 songs in 3 hours. How long will it take the band to record 9 songs if they record at the same rate? Okay, let's start with our units ratio. So what units do I see in here? Well, I see songs and I see hours. Okay? I don't necessarily see hours anywhere else, but I see how long will it take, right? That's talking about time. Okay? All right, so I'm going to do songs up top this time. So songs, we'll do it reverse. Let's put time up top. And we'll put songs in the bottom. Just so we see a slightly different fraction. Okay? All right, so a band went to recording. Student recorded 4 songs. So 4 goes in the bottom in 3 hours. 3 goes up top. Set that equal to a different scenario where they write 9 songs. 9's in the bottom. And let's use h for hours, goes up top. Okay, so let's make h equal hours. Okay, and now we solve. So I'm going to do 4 times h equals 3 times 9, which gives me 27. Now I'm ready to solve. I'm going to divide both sides by 4. 27 divided by 4 gives me h equals 6.75 hours. Great. All right, similar figures. Okay, this is a little bit of geometry. So similar figures have the same shape but are not necessarily the same exact size. You can use proportions to find missing lengths in similar figures. Okay, so just a little notation moment here. This symbol, this little like curly Q, kind of looks like this, means similar to. It means it's not equal. If you notice, these two shapes are not identical. They don't have the same side lengths. However, they're similar. Okay, they're similar, which means their angles are the same. Okay, all these angles are the same. But their side lengths aren't the same, but they're proportional. Okay, so 8 is proportional to 12. 10 is proportional to 15. 12 is proportional to 18. Okay, there's a relationship. All right, so congruent angles have the same measurement. That's what this part is saying. It means it's congruent to, meaning it's this congruent angles have the same measure. Okay, and what we just talked about here was that my ratios are equal. Okay, so that might seem confusing. It'll make more sense as we do this first problem. Okay, so notice I give you this figure. I tell you that triangle ABC is similar to triangle DEF. Okay, there's a similarity. I'm asking you, what is DE? So basically, that's wrong. I'm asking you, what is AC? So I'm asking you, what is this side length? Notice I'm given some other side lengths here. Okay. All right, so all this means is I know that AB and DE are related to each other. And I know that BC, EF are related to each other. And I know that my AC and my DF are related to each other. Okay, so we're going to set up a fraction. So looking at my sides, which sides do I have both measurements for? The blue one, okay? The blue one, I'm given 16 and I'm given 12, okay? So over here, let's just set up that fraction, okay? So if I want to put, let's do triangle ABC on top, triangle DEF, okay? So a triangle ABC, I'm told this side length is 16. So I'm going to put 16 there. At triangle DEF, the matching side is 12. All right. Now let's do the other part. So I'm looking for AC. So let's make that my variable. Let's make this my variable. And now what number would I write up top that matches? Oh, hold on. Made a mistake. I need to put the X up top because that's coming from ABC. Okay, so ABC has the X, which is why it goes up top. All right, so what number from DEF should I put in the bottom? 18, because it's the same side. All right. So setting up your proportion for these ones is the hardest part because now we just solve it as we have been. Okay, so 12 times X gives me 12X equals 16 times 18 gives me 288. Now I'm going to divide both sides by 12. And I get X equals 24. Okay. All right, we're going to use similar triangles to solve a lot of real-world problems here. So it says a sun's ray strikes a building and the girls at the same angle, forming the two similar triangles shown. How tall is the building? Okay, So I'm asking you, how tall is the building? So just like any word problem, let's define our variable. Okay? So we're going to have x equal the height of the building. So that's what I'm being asked to find. Now it tells me that since the sun is striking, so that's what this is saying, here's the sun is striking at the same angle, okay, which means my two triangles here, triangle 1, triangle 2, are similar, okay. That being said, I can set up a proportion, okay, so let's make our units ratio here. And for my units this time, it might be a little harder to see, okay? But when you think about this, when the sun strikes you, and what would we call that little piece of a person? It would be their shadow, okay? So let's use shadow as one of our units. And yet, let's use the height as our other unit, okay? So we've got the height of the girl or height of the building, and then we have the girl's shadow or the building shadow, okay? So here's my proportion. Let's just set it up, okay? So let's do the girl first, okay? So here's our girl. The girl I know is 5 feet tall, so that's her height, and her shadow is 3 feet tall. Perfect. Now let's do the building. The building height is x. That's what I don't know. That's what I'm trying to find. And its shadow is 15. Okay. From here, I'm going to do cross multiplication. So I have 3x equals 5 times 15 gives me 75. 75 divided by 3 is going to give me 25. So x equals 25. This is the height of our building, so it's measured in feet. Now, with these ones, I would like us to use a sentence because there's multiple heights and shadows and things going on. So tell me what this 25 feet is measuring. So we would say the building is 25 feet tall. Okay? That would be my sentence. Okay, the scale on a make is 1 inch by 110 miles. The distance from Jacksonville to Gainesville on the map is about 0.6 inches. What is the actual distance from Jacksonville to Gainesville? So, find your question. What is the actual distance from Gainesville? That is telling me what my variable is. Okay, so let's make D equal distance. Okay, from, and I'm going to abbreviate J to G, okay? Distance from J to G, okay? All right, now it gives me a scale, okay? So it's giving me one of my fractions. So it doesn't matter how you write it. Let's say we do 1 over 110. The only thing that matters is we keep our units the same. So 1 was talking about inches and 110 was talking about miles. Okay, so we have to make sure in our second fraction we're keeping that consistent. Okay, so it says that on the map, Jacksonville to Gainesville is about 0.6 inches. Okay, so inches. So we're going to put that up top. Okay, and the actual distance in miles is my variable. Okay, now we solve. So I'm going to do 110 times 0.6. Okay, and we get 66 equals 1 times D gives me 1D. Now 1 times D is just 1, or we could divide both sides by 1 and we would get 66 equals D. Okay, now this is mileage, so let's just write our sentence. We would say Jacksonville to Gainesville is 66 miles apart. Okay? And there we have it. All right, I want you to try our next one. So try number 2. You can pause. Okay, so it says the scale modeling of a building is 6 inches tall. The scale of the model is 1 inch by 50 feet. How tall is the actual building? Okay, so here's my question again. How tall is the actual building? So that's going to be, let's use H for height. Okay, so this is the height of the building. Okay. All right, so now it says the scale model of the building is 6 inches. The scale of the model is 1 inch over 50 feet. Okay, so for my 50 feet, that would go on the bottom. Okay, and my 1 inch would be in the top. Okay, now let's remember to keep our units consistent. So I'd have feet in the bottom and inches up top. Now we have to keep that the same when we write our second fraction. Okay, so it says a scale model of the building is 6 inches tall. So let's put that up top. And I don't know the actual height. That's what I'm trying to find. So let's put our H on the bottom. Okay, now we're ready to simplify. I'm going to do 50 times 6 and get 300 equals 1 times H. Now 1 times H is just H. So H equals 300. Let's write our sentence. The building is 300. And then what units do I want? Feet tall. Okay. And that is it.